Look at your hand right now. Go ahead, really look at it. The hand can do things no other creature on Earth can do. It can write poetry, perform surgery, play a violin, paint the Sistine Chapel. But 7 million years ago, hands that looked almost like yours were doing something much simpler. They were gripping tree branches in the forest of Africa, belonging to creatures that weren't quite apes, and definitely weren't human. So here's the question that keeps scientists up at night. At what point did we stop being them and start being us? Tonight, we're going back, way back. We're going to trace the entire journey from that first ancestor who dared to stand upright to you, lying here in the dark, listening to this story. And I promise you, it's going to be way stranger and more incredible than anything you learned in school. Picture this. It's 7 million years ago. The sun is setting over the African savanna, painting the sky in shades of orange and red. A small creature, no bigger than a chimpanzee, is moving through tall grass. But something's different about the way it moves. Every few steps it stands upright, just for a moment. Just long enough to see over the grass, to scan for predators, to spot distant fruit trees. It doesn't know it, but this simple act, standing on 2 legs, is the first step in a journey that will change everything. That creature had no idea that millions of years later, its descendants would build cities, split atoms, and leave footprints on the moon. It was just trying to survive another day. But that's how all great journeys begin. Not with grand plans, but with small adaptations that somehow, against all odds, lead to something extraordinary. Over the next few hours, as you drift off to sleep, we're going to walk through 7 stages of human evolution. 7 chapters in the most epic survival story ever told. We'll meet Sahelanthropus, that earliest whisper of humanity, barely different from an ape. We'll stand with Australopithecus, the southern ape walkers who mastered the art of moving on 2 legs. We'll watch Homo habilis pick up the first stone tool and change the rules of survival forever. Then things get really interesting. We'll travel with Homo erectus, the first human ancestor to leave Africa and explore the world. We'll encounter Homo heidelbergensis, the pioneer who survived ice ages and gave rise to multiple human species. We'll meet the Neanderthals, those misunderstood cousins whose DNA still flows through most of our veins. And finally we'll arrive at Homo sapiens, us, the storytellers who somehow outlasted everyone else and inherited the earth. But here's what's wild. This isn't just ancient history. Every stage of this journey is still written in your body right now. The way your spine curves, that's from Australopithecus learning to walk upright. The shape of your skull, that's from Homo erectus adapting to new environments. Those wisdom teeth that don't quite fit in your mouth. Genetic echoes from ancestors with bigger jaws. You're not just related to these ancient humans. You're literally built from the blueprints they created through millions of years of trial and error. And if you're using this to fall asleep, that's exactly why I make these. So maybe hit subscribe and tell me, where are you right now and what time is it? I love checking the comments and seeing Tokyo at dawn, Toronto at midnight, all these different moments happening at once. It's kind of perfect for a video about deep time. Now before we begin, I need to tell you something that's going to change how you think about human evolution. Everything you learned in school about our ancestors being primitive, brutish, unintelligent, that's mostly wrong. The Neanderthals weren't stupid cavemen. They had brains as large as ours, maybe larger. They created art, buried their dead with flowers, and survived in environments that would kill most modern humans within days. And here's the part that really messes with your head. For most of human evolutionary history, we weren't alone. Multiple species of humans walked the earth at the same time. They met each other, competed for resources, and yes, sometimes they had children together. That's why most people today carry Neanderthal DNA. We didn't just replace them, we absorbed them. Their genes, Their adaptations, their survival strategies, all became part of us. The story we're about to tell isn't a straight line from primitive to advanced. It's messier than that, more beautiful, more human. It's a story of dead ends and lucky breaks, of species that thrived for millions of years and then vanished, of adaptations that seemed useless until suddenly they became the key to survival. So get comfortable. Let the world outside fade away. Because we're about to journey back to the beginning, to a time before language, before fire, before anyone could even imagine what humanity would become. It starts 7 million years ago, in the forests and grasslands of Africa, with a creature that barely looks human at all. Let's go back, way back. Before the bottleneck, before the ice ages, before anything we'd recognize as human civilization. Back to a time when our lineage was just beginning to diverge from the path that would lead to chimpanzees. Back to the moment when something unprecedented started happening in the forests and grasslands of Central Africa. July 19th, 2001. The Jurab Desert in northern Chad. A place so hostile, so relentlessly hot and dry that it's hard to imagine anything living there, let alone something that would rewrite the entire story of human origins. But that's exactly what happened when a team led by French paleontologist Michel Brunet made one of the most significant fossil discoveries of the 21st century. They found a skull, weathered, partially crushed, about the size of a chimpanzee's head. They nicknamed it Tumai, which in the local Goran language means hope of life, a name traditionally given to children born just before the dry season. It was a fitting name for what they'd discovered. Because this skull represented the hope of understanding where we came from, the first whisper of an answer to humanity's oldest question. Where did we begin? The skull was 7 million years old. Let that sink in for a moment. 7 million years. This creature lived closer in time to the dinosaurs than to us. When Tumai walked the earth, the Mediterranean Sea was just beginning to form. The Sahara Desert didn't exist yet. The entire landscape of Africa was radically different. And somewhere in this ancient world, something was happening that had never happened before. A population of apes was beginning to walk upright. Now, here's where things get complicated. Because Sahelanthropus chadensis, that's the official name they gave to Tumai's species, shouldn't exist. Not where it was found, anyway. Before this discovery, every paleoanthropologist on Earth would have told you that human evolution happened in East Africa, the Great Rift Valley, Kenya, Tanzania, Ethiopia. That's where the fossil record was concentrated. That's where the genetic evidence pointed. That's where humanity was supposed to have been born. But here was Tumai, sitting in Central Africa, 2,500 kilometers west of where it had any business being. This wasn't just an interesting fossil. This was evidence that forced scientists to completely rethink the geography of human origins. Our ancestors weren't confined to some narrow valley in East Africa. They were spread across a massive region, possibly the entire continent, which means the story is bigger, more complex, and more uncertain than we'd ever imagined. But what made Tumai so important wasn't just where it was found. It was what the skull revealed about how this creature moved. There's this little hole at the base of your skull called the foramen magnum. It's where your spinal cord connects to your brain. In four-legged animals, this hole is positioned toward the back of the skull, because the spine approaches horizontally. In humans, it's positioned right underneath the skull, because our spine comes up vertically when we stand upright. Tumai's foramen magnum is positioned underneath the skull. Not quite as perfectly centered as in modern humans, but much more central than in any ape. This is evidence, controversial but compelling evidence, that Sahelanthropus walked upright at least some of the time. 7 million years ago, Something that looked like an ape from the neck up was walking like a human from the neck down. This is the earliest whisper of what would eventually make us human. Not intelligence, not tool use, not language. Walking upright. But why? Why would a creature that had been perfectly successful as a tree-dwelling, knuckle-walking ape suddenly start experimenting with bipedalism? The answer lies in what was happening to Africa 7 million years ago. Picture this. The continent is drying out. Not catastrophically, not quickly, but gradually over hundreds of thousands of years. The dense tropical forests that had covered much of Central and Eastern Africa are fragmenting, breaking up into a mosaic of woodland patches separated by increasingly large areas of grassland. For most apes, this is bad news. Chimpanzees, gorillas, the entire family of apes that would eventually stay apes, they're forest specialists. They need trees. When the forests fragment, their populations fragment with them. But for one small population, maybe living somewhere near what's now Chad, this environmental change created an opportunity instead of a crisis. The grasslands between forest patches meant danger, open spaces where predators could spot you easily. But they also meant food, seeds, tubers, small animals, resources that weren't available in the crowded forests. Walking upright solved multiple problems at once. Standing up lets you see over tall grass, spot predators before they spot you. It frees your hands to carry things, food, infants, tools eventually. Most importantly, it's more energy efficient for long-distance travel across open ground. A bipedal ape can cover more territory with less effort than a knuckle walker, which matters enormously when resources are scattered across a fragmenting landscape. So, natural selection started favouring individuals who were better at walking upright. Not perfectly, not exclusively. Sahelanthropus probably still spent plenty of time in trees. The fragments of skull we have show evidence of powerful jaw muscles and large canine teeth, suggesting they were still doing plenty of tree climbing, still eating tough plant materials that required serious chewing power. They were transitional, part ape, part something new, the earliest experiment in becoming human. But here's the uncomfortable truth. We don't know if the experiment worked. We don't know if Sahelanthropus is actually our ancestor, or just an evolutionary dead end, a failed attempt at bipedalism that went extinct without leaving descendants. And the reason we don't know is because the fossil record from this period is desperately incomplete. Think about what we're working with here. One partial skull, a few teeth, some jaw fragments. That's it. That's the entire physical evidence for this species. Everything else is inference, educated guessing based on comparative anatomy and evolutionary theory. We don't have leg bones to confirm bipedalism. We don't have pelvis fragments to understand locomotion. We don't have enough material to even know for certain that all these fragments came from the same species. Some scientists look at Tumai and see the earliest human ancestor, the root of our family tree. Others see an early ape that happened to have some human-like features, but wasn't actually related to us at all. Still others think Sahelanthropus might be ancestral to both humans and chimpanzees, a creature that lived before the split, before our lineages diverged into separate paths. The honest answer is we don't know, and we might never know unless we find more fossils. But that uncertainty is actually telling us something important about how evolution works. Evolution doesn't have a goal. It's not trying to produce humans. It's just populations adapting to immediate environmental pressures, solving the problem of survival in whatever way works. Some solutions lead to new species, others lead nowhere. We only notice the successful lineages because we're here to notice them. The failures disappear without a trace. Sahelanthropus might have been a failure, a population that tried walking upright, found it worked pretty well, flourished for a few 100,000 years, and then went extinct when the climate shifted again, or a disease swept through, or some other population outcompeted them. If that's what happened, then somewhere else in Africa, a different ape population was independently evolving bipedalism. That population would be our actual ancestors, and Tumai would just be a fascinating footnote, evidence that evolution sometimes tries the same solution multiple times. Or Sahelanthropus might have been the real deal, the actual root of the human family tree. Those 7 million-year-old footsteps in the African grasslands might have been the first steps on a journey that would eventually lead to every human who has ever lived. We might all be descendants of Tumai's population, carriers of genes that first emerged in Central Africa when the forests began to fragment. The maddening thing is both scenarios fit the available evidence. The skull is ambiguous enough, the fossil record sparse enough, that scientists with equal expertise and equal access to the data can reach completely opposite conclusions. Some look at the position of the foramen magnum and see clear evidence of habitual bipedalism. Others look at the same feature and see a climbing adaptation that happens to resemble bipedalism. Some look at the wear patterns on the teeth and see a diet that requires travelling long distances between food sources. Others see an ape that never left the forest. This uncertainty drives some people crazy. They want clear answers, a straight line from Sahelanthropus to Australopithecus to Homo sapiens. They want a family tree with solid branches and clear relationships. But evolution doesn't work like that. Evolution is messy, full of false starts and dead ends and populations that blur together. The human fossil record looks less like a tree and more like a tangled bush, with branches growing in every direction. And honestly, the uncertainty makes the story more interesting, not less. Because what we're looking at with Sahelanthropus isn't just one creature or one species. We're looking at a moment of transformation in African ecology, a time when the old stable forest ecosystems were breaking down and something new was emerging, multiple ape, populations responding to these changes in different ways, some staying in the shrinking forests, some moving into the grasslands, some experimenting with new forms of locomotion, most going extinct, a few succeeding. Somewhere in that chaotic period of experimentation, humanity began. Not as a predetermined outcome, not as the inevitable result of some progressive march toward perfection, just as one successful adaptation among many failures. One population that figured out how to exploit a new ecological niche and managed to survive long enough to pass on their innovations to the next generation. Tumai gives us a glimpse of that moment, whether or not Sahelanthropus was directly ancestral to us. The skull proves that 7 million years ago, something was already experimenting with the adaptations that would define humanity. Walking upright, venturing into open grasslands, developing the anatomical changes that would eventually free our hands for tool use and our brains for expansion. The whisper had begun, a whisper that would grow louder over the next 7 million years until it became the voice of a species capable of wondering where it came from, capable of digging up ancient skulls in desert badlands and recognizing them as mirrors of our own deep past. But Sahelanthropus was just the beginning, just the first tentative step, the creature that walked away from the forest 7 million years ago barely resembled a human. If you could travel back in time and see Tumai in the flesh, you'd probably think you were looking at a weird chimpanzee. Small brain, ape-like face, probably covered in hair. The only hint of what was coming would be the way it moved when it ventured into the grasslands, standing upright on two legs, scanning the horizon for dangers and opportunities. That posture, that simple mechanical adaptation to a changing environment, set in motion a cascade of evolutionary changes that would transform everything. Because once you start walking upright regularly, natural selection starts reshaping your entire body. Your spine curves differently, your pelvis narrows and rotates, your legs lengthen and straighten, your feet develop arches, your hands, no longer needed for walking, become more dexterous. And eventually, much later, your brain begins to expand because bipedalism freed up energy that was previously devoted to maintaining powerful shoulder and arm muscles for climbing. But all of that was still millions of years in the future. For now, 7 million years ago in the fragmenting forests of Central Africa, Sahelanthropus chadensis was just trying to survive in a changing world, eating what it could find, avoiding predators, raising offspring, living and dying in the endless cycle of life that has characterized existence on this planet for billions of years. Most of them left no trace, their bones scattered and dissolved in the African soil, their lives forgotten the moment they ended, but one skull survived. One fragment of bone weathered 7 million years of geological upheaval and climate change, and finally eroded out of the desert hardpan at exactly the right moment for a team of paleontologists to find it. That's the only reason we know Sahelanthropus existed at all. Pure luck. The accident of fossilization meeting the accident of discovery, which means there were probably dozens, maybe hundreds of other species living alongside Sahelanthropus. Other experimental apes trying other solutions to the problem of surviving in a fragmenting forest landscape. We'll never know their names, we'll never find their bones. They're lost to deep time, as invisible to us as if they'd never existed. But they were there, living, adapting, mostly failing. All part of the great churning engine of evolution that was trying every possible solution to every possible problem. And somewhere in that chaos of experimentation, one lineage found a solution that worked. A way of moving, a way of living, that would prove viable for the next 7 million years. Whether that lineage included Sahelanthropus or not, we may never know for certain. But we know the experiment succeeded. We know that something very much like Tumai walked out of the forests and into a new world, and in doing so took the first step on a journey that would eventually lead to everything we are today. The whisper had begun, but it would be a long time before anyone was around to hear it clearly. November 24, 1974. The Afar Desert in Ethiopia. It's 110 degrees in the shade, except there is no shade. A young paleoanthropologist named Donald Johansen is walking back to camp after another long day of finding nothing. His team has been searching this desolate landscape for weeks, turning up fragments, bits of animal bone, nothing remarkable. He's tired, dehydrated, ready to call it a day. But his colleague Tom Gray convinces him to check one more gully. They're walking along, barely paying attention, when Johansen sees something, a fragment of bone sticking out of the slope. He kneels down. It's an arm bone, definitely primate, possibly human ancestor. Then he sees another bone a few feet away, and another, and another. Within minutes they realize they're looking at something unprecedented. Not just a few fragments, not just a partial skeleton, but a nearly complete individual, 40% of an entire skeleton, 3.2 million years old, lying in the Ethiopian desert, waiting to be found. That night, back at camp, the team is celebrating. Someone puts on a cassette tape. The Beatles. Lucy in the Sky with Diamonds plays on repeat while they drink beer and talk excitedly about the fossil they've found. And somewhere in the alcohol-fueled celebration, someone suggests they name her Lucy. She became the most famous fossil in the world. Not because she was the oldest, not because she was the most complete, but because she was the first time most people could look at a human ancestor and see an actual individual, not just fragments and speculation, but a real person who had lived and died millions of years ago. Lucy was an Australopithecus afarensis. The name means southern ape from the Afar region. She stood about 3.5 feet tall, weighed maybe 60 pounds, had a brain about the size of a chimpanzee's, but here's what made her and her kind revolutionary. She walked upright, not occasionally, not just when it was convenient, full time. Committed bipedalism. Her hip bones tell the story. They're shorter and broader than a chimpanzee's, repositioned to support weight from above rather than from the side. Her femur angles inward toward the knee, creating the knocked knee stance that lets bipeds balance their center of gravity over their feet. Her feet themselves show the distinctive arch and shortened toes of a habitual walker. This wasn't an ape that sometimes walked upright. This was a biped that sometimes climbed trees, and yes, she still climbed. Her arms were proportionally longer than modern humans, her fingers curved, perfect for grasping branches. Her shoulder joints retained the mobility needed for overhead climbing. She hadn't abandoned the trees entirely, but her primary mode of transportation was walking, step by step across the African savanna. But why? Why trade the safety of the forest canopy for the dangers of open ground? The old theory said it was about tools, freeing up the hands to carry things, to make implements, to throw weapons. But Australopithecus didn't make tools, at least not stone tools. They came later. So what was the advantage? The answer is efficiency. Walking on two legs uses about 75% less energy than walking on all fours. For an animal trying to survive in an environment where food sources are scattered and unpredictable, that efficiency is everything. It means you can range farther, cover more territory, access resources that would be unreachable for a quadruped burning energy with every step. Think about it. The forests were fragmenting. Climate change was turning continuous woodland into a patchwork of forest islands separated by open grassland. To get from one food source to another, you had to cross exposed terrain. The individuals who could do that most efficiently, who could walk farther with less energy expenditure, they were the ones who survived. They were the ones who reproduced. Generation after generation, natural selection refined the bipedal adaptation until it became the defining feature of our entire lineage. But the most remarkable evidence of Australopithecus bipedalism wasn't Lucy. It was footprints, actual footprints preserved in volcanic ash for 3.6 million years. 1978, Litoli, Tanzania. Paleoanthropologist Mary Leakey and her team are excavating when they discover something that should be impossible. A layer of volcanic ash, laid down during an eruption millions of years ago, has preserved a moment in time. The ash fell during the rainy season, creating a cement-like surface, and before it hardened completely, 3 individuals walked across it, going north, purposefully. One adult, probably female based on the foot size, another larger adult walking beside her, and a juvenile stepping carefully in the adult's footprints. You can see everything. The weight distribution, the heel strike, the push-off from the ball of the foot, the distinctive arch that marks human-style walking. These weren't apes shuffling awkwardly on 2 legs. These were committed bipeds moving with confidence across open terrain. But here's what makes the Litoli footprints profound. They captured a moment of behavior, not just anatomy, but action. 3 individuals traveling together, a family group probably, moving through a landscape still steaming from a volcanic eruption, their feet pressing into fresh ash. Were they fleeing the eruption, returning to a home territory after the danger passed? We'll never know. But for a moment, 3.6 million years later, we can see exactly where they walked, and imagine why. The brain inside Lucy's skull measured about 400 cubic centimeters. That's roughly the same as a modern chimpanzee, about a third the size of a modern human brain. Some scientists look at that and conclude Australopithecus couldn't have been very intelligent. But that's missing the point. Brain size matters, but it's not everything. What matters is brain organization, how the different regions are structured, what they're capable of processing, and while we can't examine a living Australopithecus brain, we can make inferences from behaviour. They were bipedal, which requires sophisticated balance and motor control. They lived in complex social groups which demand social intelligence. They ranged across varied environments, exploiting different food sources seasonally, which requires memory and planning. Their brains might have been chimpanzee-sized, but they were solving problems that chimpanzees never faced. And that selection pressure, that constant demand to navigate a challenging and changing environment, that's what started driving brain evolution forward, slowly at first, almost imperceptibly across the generations, but directionally, toward larger, more complex, more capable brains. Australopithecus wasn't one species. It was a whole genus, multiple species, evolving in parallel, each adapting to slightly different niches across Africa. Australopithecus afarensis, Lucy's species, lived in East Africa from about 4 to 3 million years ago. They were the generalists, capable of exploiting a wide range of foods and environments. Their jaw structure shows they ate fruits, leaves, seeds, maybe even some meat when they could scavenge it. They were the survivors, the adaptable ones. Then there was Australopithecus africanus, living in southern Africa from about 3 to 2 million years ago. Slightly larger brains, more robust jaws, teeth. Adapted for tougher foods, they were dealing with a drier, more seasonal environment, and their anatomy reflects that challenge. But the most dramatic adaptation came with the robust Australopithecines, species like Australopithecus robustus and Australopithecus boisei. These were the specialists, the ones who went all in on a particular survival strategy. They developed massive jaws, enormous molars, thick tooth enamel. Their skulls grew sagittal crests, bony ridges that anchored jaw muscles powerful enough to crack open nuts and seeds. They became eating machines, specialized for processing tough, fibrous plant material. Look at an Australopithecus boisei skull, and it's immediately obvious what they were designed for. The face is flattened, the cheekbones flared outward, the molars so large that early anthropologists nicknamed them Nutcracker Man. These were creatures that had solved the food problem by specializing. While other species competed for fruits and meat, they focused on resources nobody else could access efficiently. Seeds, nuts, tough roots, the hard, low-quality foods that were always available even during droughts. For a while, this strategy worked brilliantly. The robust species spread across East and Southern Africa, thriving in environments that would have challenged the more generalized species. But specialization comes with a cost. It makes you vulnerable to change, and change was coming. Between 3 and 2 million years ago, Africa was transforming again. The climate was becoming even drier, even more seasonal. Forests continued shrinking, grasslands expanded, and the robust Australopithecines, so perfectly adapted to one particular niche, found themselves in trouble. When the plant species they depended on started declining, they had nowhere to turn. Their massive jaws and specialized teeth locked them into a dietary strategy that was becoming obsolete. One by one, the robust species went extinct. Australopithecus robustus vanished around 1.2 million years ago. Australopithecus boisei held on longer, surviving until about 1 million years ago, but eventually they too disappeared from the fossil record. The generalists survived, the flexible species, the ones who could eat anything, exploit any resource, adapt to any environment. They weren't necessarily smarter or stronger, they were just less committed to any one strategy. But what about their social lives? How did Australopithecus organize themselves? Who mated with whom? How did they raise their young? We can't observe them directly, but the fossil record provides clues. At sites across Africa, we find multiple Australopithecus individuals buried together. not necessarily at the exact same time, but in the same locations, suggesting these places were important to them. Gathering spots, maybe. Places groups return to repeatedly. The size difference between males and females tells another story. Male Australopithecus specimens are consistently larger than females, not just a little bigger, significantly bigger, about 50% more body mass in some species. This pattern shows up in primate species that live in multi-male, multi-female groups where males compete aggressively for access to females. So picture Australopithecus social structure like this. Groups of maybe 20 to 40 individuals, multiple adult males, multiple adult females, various juveniles at different ages, the males competing with each other, sometimes violently, for dominance and mating opportunities. The females forming alliances, cooperating in child rearing, maintaining the social stability that kept the group functional. Infant Australopithecus stayed with their mothers for years, learning the locations of food sources, the techniques for processing different plant materials, the social rules that governed group interactions. Childhood was long because there was a lot to learn, and mothers invested heavily in each offspring because infant mortality was brutal. Predators, disease, accidents, starvation during droughts. Most infants probably didn't survive to adulthood. The individuals who made it were the lucky ones, born with good genes, raised by competent mothers, living in successful groups, and they passed on whatever advantages they possessed to the next generation, slowly, incrementally, improving the species through natural selection. For 2 million years, various species of Australopithecus dominated the African landscape. They perfected bipedalism. They developed complex social structures. They adapted to environmental challenges that would have destroyed less flexible creatures. But they remained fundamentally ape-like. Their brains didn't grow much. They didn't develop material culture beyond the simplest possible tools, probably wooden implements that didn't preserve. They didn't spread beyond Africa. They were successful, but they were limited, trapped by their biology, their small brains, their dietary constraints. They had taken the first crucial step toward humanity by walking upright. But walking upright wasn't enough. The next stage would require something more. Something that would begin to separate our ancestors from every other creature on the planet. Around 2.4 million years ago, one lineage of Australopithecus began changing in a new direction. Their brains started growing, their teeth started shrinking, their hands started showing the precision grip needed for detailed manipulation. They were becoming something else, something that would earn a new name, Homo, the human. But that transformation didn't happen in a vacuum. It happened because the world was changing again, presenting new challenges and new opportunities, and the individuals who could exploit those opportunities, who could adapt faster than their competitors, they were the ones who survived to become our ancestors. The age of Australopithecus was ending. The age of Homo was about to begin. Picture this. East Africa, 2.4 million years ago, a creature that looks almost but not quite human crouches beside a stream. In its hands, a rock. Not just any rock, but one it's been studying, turning over, examining with intense focus. Then, with deliberate precision, it strikes the rock against another stone. Once, twice, 3 times. Chips fly off. And suddenly, where there was just a rounded stone, there's now an edge, a tool, a weapon, an extension of will transformed into physical reality. This is the moment everything changes. This is when our ancestors stopped just using what nature provided and started reshaping the world to fit their needs. This is Homo habilis, the handyman, the first toolmaker, the first species that probably deserves to be called human. But here's what makes this moment so mind-blowing. That creature sitting by the stream, the one who just created the first stone tool, didn't invent the idea out of nowhere. Somewhere in its brain, probably in newly expanded regions of its prefrontal cortex, it had formed an abstract concept. It had looked at a rock and seen not what it was, but what it could become. It had imagined a shape that didn't yet exist, then figured out the sequence of actions necessary to bring that imaginary shape into reality. That's not just intelligence, that's mental time travel. That's the ability to conceive of future possibilities and work backward to figure out how to create them. That's the cognitive foundation of everything humans would eventually achieve. And we know when this happened because the archaeological record suddenly explodes with evidence. Around 2.6 million years ago, stone tools start appearing at sites across East Africa. Simple at first, just rocks with a few flakes knocked off to create a sharp edge. But unmistakable. These weren't rocks that had been naturally broken by geological processes. These were rocks that had been deliberately shaped by intelligent hands following a plan. The oldest known tools come from a site called Gona in Ethiopia, 2.6 million years old. Dozens of worked stones showing clear evidence of intentional flaking. Whoever made these tools understood the mechanics of stone fracture, knew which types of rock would flake predictably, had the manual dexterity to strike at precise angles. This was sophisticated behaviour, and it appeared seemingly out of nowhere in the fossil record. Except it didn't come from nowhere. It came from Homo habilis, or at least that's what we think. The fossil evidence gets complicated here because we're dealing with a transitional period. The later Australopithecines were still around, still successful, still doing their thing in the African woodlands. But something was changing. Some populations were evolving in a new direction, developing traits that would eventually justify creating a whole new genus. Homo, human. The first Homo habilis fossils were discovered in the 1960s at Olduvai Gorge in Tanzania, the same remarkable site that gave us so much Australopithecine material. Louis and Mary Leakey found fragmentary remains that looked different from Australopithecus. Bigger brain cases, smaller faces, more delicate bone structure. But most importantly, they found these fossils in direct association with stone tools. That's why they named the species Homo habilis, handyman, the toolmaker. They were making a bold claim that this was the first species that deserved to be placed in our genus, the first creature that was fundamentally human rather than merely human-like. But not everyone agreed then, and honestly, not everyone agrees now. Here's the problem. Homo habilis sits right at the boundary between Australopithecus and later Homo species. It has some features that look human, bigger brains, smaller teeth, more gracile builds. But it also retains lots of Australopithecine characteristics. Long arms relative to legs, curved finger bones suggesting they still spent significant time in trees, brains that while larger than Australopithecus, were still only about half the size of modern humans. Some anthropologists argue that Homo habilis should really be classified as Australopithecus habilis, that it's not different enough from the Australopithecines to warrant a new genus. Others think the species is so variable that it probably represents multiple species all lumped together under one name. The debate continues. But here's what everyone agrees on. Around 2.4 million years ago, something was changing in human evolution. Brains were getting bigger, tool use was becoming systematic, and a new survival strategy was emerging that would eventually dominate the planet. The brain size increase is particularly significant. Australopithecines had brain volumes around 400 to 500 cubic centimeters, roughly the same as modern chimpanzees. Homo habilis clocks in at 600 to 750 cubic centimeters. That's a 50% increase. That might not sound like much, but in evolutionary terms it's explosive growth happening over just a few 100,000 years. And brains are expensive. Metabolically speaking, your brain costs you enormous amounts of energy. It's about 2% of your body weight, but consumes roughly 20% of your daily calories. For early humans living on the edge of survival, Growing bigger brains was a huge evolutionary gamble. It only makes sense if those bigger brains provide equally huge survival advantages. The tool-making ability was clearly one of those advantages. But to understand why it mattered so much, you need to understand what those early tools actually did. The Old Owen tool tradition, named after Olduvai Gorge where it was first identified, consists of what archaeologists call choppers and flakes. You take a rock, called a core, and strike it repeatedly with another stone called a hammer stone. Each strike removes a flake. The flakes themselves have sharp edges that can cut. The core, after enough flakes are removed, becomes a chopper, a heavy tool with one or more sharp edges. Sounds simple, and by later standards it is. But try it yourself sometime. Try taking two rocks and creating a tool with a genuinely sharp, functional edge. It's harder than it looks. You need to select the right type of stone, something that fractures predictably like basalt, chert or obsidian. You need to understand angles, force, the mechanics of how stones break. You need manual dexterity, hand-eye coordination, and most importantly, you need to be able to hold a mental image of your goal while executing a complex sequence of actions. That last part is crucial. When you're making an older one tool, you're not just reacting to immediate stimuli. You're planning. You're imagining an end state that doesn't yet exist, then figuring out the steps to reach it. This requires what cognitive scientists call working memory, the ability to hold and manipulate information in your mind while performing complex tasks. Homo habilis had just enough of this cognitive ability to make systematic tool production possible. And once they had tools, everything changed. Because tools opened up an entirely new food source, meat. Now, Australopithecines probably ate some meat opportunistically. If they found a dead animal and could get to it before the predators did, they'd scavenge what they could. But without tools, they were limited to what they could tear apart with their hands and teeth. The best parts, the organ meats and bone marrow packed with nutrients, were locked inside skin too tough to tear and bones too hard to break. Tools changed that equation completely. A sharp stone flake could slice through hide that would resist teeth and fingernails. A chopper could smash open bones to access the calorie-rich marrow inside. Suddenly, Homo habilis could exploit carcasses that other scavengers had already picked over. The leftovers became valuable resources. The fossil evidence supports this scavenging hypothesis. At multiple archaeological sites, we find animal bones with two types of marks on them. First, tooth marks from large carnivores like lions or hyenas, showing they got to the carcass first. Then, overlaying those tooth marks, stone tool cut marks, showing Homo habilis came along later and carved off whatever meat remained or smashed the bones for marrow. This was opportunistic scavenging, not hunting. Homo habilis wasn't taking down large animals themselves. They were too small, too poorly adapted for predation. But they were smart enough to follow vultures to fresh kills, brave enough to chase off smaller scavengers, and patient enough to wait until the major predators had finished before moving in for the scraps. And those scraps mattered enormously. Meat is calorie-dense and nutrient-rich in ways that plant foods simply aren't. A kilogram of meat provides roughly twice as many calories as a kilogram of fruits or tubers. More importantly, meat provides complete proteins with all the essential amino acids needed for brain growth and maintenance. The ability to regularly access meat, even if just as a scavenger, would have provided the caloric surplus necessary to support those expanding brains. This created what scientists call a positive feedback loop. Bigger brains enabled better tool making. Better tools enabled more efficient scavenging. More efficient scavenging provided more calories. More calories supported even bigger brains. Over hundreds of thousands of years, this cycle drove continuous evolutionary change, pushing our ancestors toward larger brains and more sophisticated cognition. But here's where the timeline gets interesting and complicated. Homo habilis appears in the fossil record around 2.4 million years ago. The earliest definite stone tools date to 2.6 million years ago. So who was making those first tools? We don't have fossils of the tool makers from those earliest sites. It's possible that some late Australopithecines had figured out basic tool making before Homo habilis even evolved. It's also possible that there were very early Homo species that we simply haven't found fossils of yet. This uncertainty reflects a deeper truth about human evolution during this period. It wasn't a straight line from Australopithecus to Homo. It was a bushy family tree with multiple species coexisting, competing, maybe occasionally interbreeding. Between 2.5 and 1.5 million years ago, East Africa was home to an astonishing diversity of hominins. You had at least 2 species of Australopithecus still thriving. You had Homo habilis, and probably at least one other early Homo species, Homo rudolfensis, which some scientists think should be classified as a separate species based on slight differences in skull shape and brain size. All of these species were living in overlapping territories, exploiting similar resources, and probably watching each other warily across the African savanna. It must have been bizarre. Imagine looking across a valley and seeing creatures that look almost human but not quite, knowing they're smart enough to be dangerous but different enough to be alien. This diversity makes it hard to identify clean evolutionary transitions. Was Homo habilis ancestral to later Homo species? Probably, but maybe not directly. Was tool-making invented once and spread? Or did multiple species independently figure it out? We don't know for certain. What we do know is that by 2 million years ago, stone tool-making had become widespread across East Africa. Multiple hominin species were creating Oldowan tools. The technological revolution had begun, and once it started, it didn't stop. The archaeological record shows gradual refinement of tool-making techniques over hundreds of thousands of years. Early Oldowan tools are rough, irregular, clearly the work of beginners still figuring things out. Later Oldowan tools are more carefully made, more symmetrical, with more consistent flake patterns. This suggests learning, cultural, transmission, improvement over generations. But for a long time, the tools themselves didn't change fundamentally. From 2.6 million years ago until about 1.7 million years ago, nearly a million years, Oldowan technology remained basically static. Simple choppers and flakes, nothing more elaborate. This tells us something important about the cognitive limitations of Homo habilis. They were smart enough to make tools and teach others how to make them, but they apparently weren't quite smart enough to innovate, to imagine entirely new tool forms and manufacture them. That limitation would be overcome by the next stage of human evolution, by a species that would take everything Homo habilis learned and amplify it dramatically. But we're getting ahead of ourselves. For now, what matters is that Homo habilis had crossed a threshold. They had learned to reshape the physical world according to mental templates. They had learned to plan ahead, to imagine possibilities and work to realize them. They had learned to teach their children not just through demonstration but through active instruction, creating the first human cultural traditions. These abilities set them apart from every other animal on Earth. Yes, some animals use tools. Chimps use sticks to fish for termites. Crows use hooks to extract grubs. Sea otters use rocks to crack shells. But no other animal systematically manufactures standardized tools following learned templates and passes those techniques down through generations as cultural knowledge. That's what makes Homo habilis special. Not that they were smarter than apes, though they were. Not that they walked upright, because the Australopithecines had already figured that out. What makes them special is that they were the first species to exist partially outside of pure biological evolution. They were creating culture, simple culture, limited culture, but culture nonetheless. And culture evolves faster than genes. Once you can pass knowledge down through generations, each generation can build on what came before. You're not starting from scratch every time. You're accumulating wisdom, techniques, solutions to problems. Homo habilis lived for about 1 million years, from 2.4 to 1.4 million years ago. During that time, they spread across East and South Africa. They refined their scavenging techniques. They improved their tools, at least incrementally, and they set the stage for everything that would come after, because they proved something crucial. They proved that big brains and tool-making ability provided real survival advantages. They proved that investing metabolic resources in cognition could pay off. They proved that the path forward for human evolution would be through increasing intelligence rather than increasing size or strength. The animals that would dominate the planet wouldn't be the biggest or fastest or strongest. They would be the smartest, the ones who could outthink rather than outfight their competitors. And it all started with Homo habilis, the handy man, the first toolmaker, the first species to look at the world and see not just what was, but what could be, the first species to imagine a better tool, a better strategy, a better future, and then make it real through the work of their hands. But they were just the beginning, the foundation, the proof of concept. What came next would take everything they pioneered and scale it up to something extraordinary. The first humans who would walk out of Africa and claim the entire world as their territory. The travellers, the wanderers, the species that would prove that humans didn't just belong in East African woodlands, but could adapt to and thrive in virtually every environment on Earth. That story comes next. But first, appreciate what Homo habilis accomplished. With brains barely half the size of ours, living on the knife edge of survival, they figured out something revolutionary. They figured out that intelligence and innovation could overcome almost any physical limitation. That a clever mind with a sharp stone could outcompete bigger, stronger, faster animals. That the future belonged not to the mighty, but to the clever. They were right, and we're all living proof. Now something truly extraordinary happens. Something that had never occurred before in the entire 4 billion year history of life on Earth. A species of primate, barely 1.5 million years removed from tree-dwelling ancestors, decides to leave Africa and walk into the unknown. This is Homo erectus, the traveller, the adventurer, the species that would prove humans were never meant to stay in one place. 1.9 million years ago, somewhere in East Africa, your ancestors stood on 2 legs and looked north. They had already evolved past Homo habilis. They were taller now, with legs built for distance and bodies that could handle sustained walking. But more importantly, they had something their predecessors lacked. They had the technology and the courage to venture into territories where no primate had ever survived. And they walked. Not in one great exodus, not as a single migration, but in waves over hundreds of thousands of years. Groups splitting off, following game animals, chasing seasonal resources, exploring river valleys that led away from familiar territories. Some of these groups failed, died out in unfamiliar lands, but others survived, adapted, and kept going. Within just a few 100,000 years, Homo erectus had accomplished something that would have seemed impossible to their ancestors. They had spread across Asia. From the grasslands of Georgia to the tropical islands of Indonesia, from the temperate forests of China to the Mediterranean coast, they became the first truly global human species. The fossil evidence is staggering. In 1891, a Dutch physician named Eugène Dubois discovered bones on the island of Java that would change our understanding of human evolution forever. He called his find Java Man, but it was actually Homo erectus, living on a tropical island over 8,000 miles from where the species first evolved. That's not migration, that's conquest. That's a species looking at oceans and mountains and saying, we can cross that. In the 1920s, excavations at Zhoukoudian near Beijing uncovered evidence of Homo erectus living in China over 750,000 years ago. They called this find Peking Man, and the remains told an incredible story. These weren't just survivors who had stumbled into Asia by accident. These were successful, thriving populations who had mastered their environments completely. But how? How does a species with a brain only 2/3 the size of a modern human's manage to colonize 3 continents? How do they survive in climates ranging from tropical heat to near Arctic cold without the technology we consider essential for survival? The answer is fire. Sometime around 1.5 million years ago, possibly earlier, Homo erectus learned to control fire, not just use it when they found it, not just maintain fires started by lightning strikes. They learned to make it, to create fire on demand, to carry it with them, to keep it alive. This is one of the most important moments in human history. More important than the wheel, more transformative than agriculture. Fire changed everything. Think about what fire means when you're a primate trying to survive outside Africa. First, it's warmth. Suddenly you can live in colder climates. You can survive nights that would have killed your ancestors. You can expand your range into territories that were previously uninhabitable. Second, it's protection. A fire keeps predators away. For the first time in primate history, humans could sleep safely on the ground. No need to climb trees every night or find caves. Just build a fire and create a circle of safety that no lion, no hyena, no saber-toothed cat would cross. Third, and most importantly, it's cooking. This changes everything about human evolution. Raw meat is tough, hard to digest, potentially full of parasites. Raw plants are often toxic or require massive amounts of chewing to extract nutrients. Your ancestors before Homo erectus spent hours every day just chewing food, trying to extract enough calories to survive. But cooked food is pre-digested. The heat breaks down tough proteins, destroys toxins, kills parasites, makes nutrients more bioavailable. A cooked meal provides more calories for less effort than raw food ever could. The implications are staggering. With cooking, Homo erectus could extract more energy from less food. They could spend less time eating and more time doing other things, exploring, innovating, socializing, and most importantly, they could fuel larger brains. Brain tissue is incredibly expensive metabolically. Your brain makes up only 2% of your body weight but consumes about 20% of your energy. For brain size to increase, you need a reliable source of high-quality calories. Cooking provided exactly that. Archaeologists have found hearths, fire-cracked rocks, and burned bones at Homo erectus sites across Africa and Asia. At Gesher Benot Yaakov in Israel, there's evidence of controlled fire use dating back 790,000 years. At Zhoukoudian in China, layers of ash several meters thick tell us Homo erectus maintained fires continuously for generations. But fire did something else too, something less tangible but perhaps even more important. Fire created a gathering place, a center point for social activity. For the first time, humans had a reason to sit in one spot for extended periods. While food cooked, while the fire burned, they could talk, share information, tell stories about the day's hunt or tomorrow's journey. This is where language might have really taken off. Not just grunts and gestures, but actual complex communication. Sitting around fires night after night, generation after generation, selecting for individuals who could communicate more effectively, who could share knowledge more clearly. Fire became the first classroom, the first theatre, the first town hall. Homo erectus was also innovating in other ways. They created what archaeologists call Acheulean hand axes, and these tools are remarkable for reasons that might not be immediately obvious. They're beautiful, first of all, symmetrical, carefully crafted, shaped with clear intentionality. But what's really remarkable is their consistency. Acheulean hand axes appear in the archaeological record about 1.76 million years ago, and they continue virtually unchanged for over 1 million years. You can find nearly identical hand axes in Kenya and in England, separated by thousands of miles and hundreds of thousands of years. This tells us something profound about Homo erectus culture. They had developed a teaching tradition, a way of passing knowledge from generation to generation so precisely that tool designs remained standardized across vast distances and time periods. This isn't instinct. No other animal maintains cultural traditions with this kind of fidelity. This is learned behavior, transmitted through demonstration and practice. Some archaeologists call this cultural conservatism, and they don't always mean it positively. Why did Homo erectus make essentially the same tool for 1 million years? Why didn't they innovate more rapidly? But maybe they're asking the wrong question. Maybe the remarkable thing isn't the lack of change, but the incredible success of the design. If you create a tool that works perfectly for 1 million years, why change it? Physically, Homo erectus was becoming something that would look surprisingly familiar to you. They had essentially modern body proportions. Long legs built for efficient walking and running, shorter arms no longer adapted for tree climbing, a narrower pelvis and more upright posture. If you dressed a Homo erectus in modern clothes and put them on a subway, you might not look twice. At least not until you saw their face. Their skulls were different. Lower, more elongated, with pronounced brow ridges and a brain case averaging about 900 cubic centimeters, compared to the modern human average of 1,350. But that's still double what Homo habilis had, and considerably larger than any other primate. They were getting smarter, generation by generation, and they were getting more social. The evidence suggests Homo erectus lived in larger groups than their predecessors. They coordinated hunts, shared food, cared for sick and injured individuals. At Dmanisi in Georgia, archaeologists found the skull of an old Homo erectus individual who had lost all but one tooth. This person couldn't have chewed raw food effectively. They would have needed others to help them eat, probably by pre-chewing food or preparing soft-cooked meals. This individual survived years after losing their teeth. Someone was taking care of them, feeding them, protecting them. This is compassion. This is society. This is humans looking after each other, not because it's evolutionarily advantageous, but because it's the right thing to do. The question of language in Homo erectus is contentious. We have no direct evidence. Language doesn't fossilize. But the circumstantial evidence is compelling. They had the technological sophistication to master fire and create standardized tools. They coordinated complex activities like long-distance migration and group hunting. They maintained cultural traditions across vast distances and time periods. All of this suggests fairly sophisticated communication. Maybe not language as complex as modern humans possess, but probably something more advanced than simple gestures and grunts. Perhaps a proto-language with basic grammar, capable of conveying concrete information about locations, resources, and dangers, enough to teach tool-making, plan hunts, and pass on knowledge about fire management. Some researchers point to the structure of the inner ear in Homo erectus fossils, which suggests they could perceive sounds in the frequency range of human speech. Others look at the position of the larynx and the shape of the thoracic vertebrae, which in Homo erectus show adaptations consistent with the kind of breath control needed for sustained speech. We may never know exactly how Homo erectus communicated, but they clearly communicated effectively enough to become the most successful human species that has ever existed. Not in terms of technology or cultural achievement, but in terms of pure survival. Homo erectus lasted for nearly 2 million years. That's longer than any other human species before or since. Modern humans, Homo sapiens, have only been around for 300,000 years. We're evolutionary newborns compared to Homo erectus, and yet we're the ones who survived while they disappeared. Why? The answer might be that Homo erectus was too successful. They had found a formula that worked: mastery of fire, efficient hunting, standardized tools, and they stuck with it. For 1 million years, while the climate changed, while other species evolved and went extinct, Homo erectus just kept doing what worked. But eventually, that conservatism became a limitation. Around 400,000 years ago, new human species began appearing. Species that innovated faster, adapted more quickly, developed more sophisticated technologies. Homo heidelbergensis in Africa and Europe, Homo neanderthalensis in the north, and eventually Homo sapiens in Africa. These newcomers had learned from Homo erectus, built on their achievements, and then surpassed them. Better tools, more complex social structures, enhanced cognitive abilities. By 110,000 years ago, the last populations of Homo erectus were disappearing, outcompeted by their more advanced descendants. But calling them failures would be missing the point entirely. Homo erectus succeeded for 2 million years. They conquered 3 continents. They mastered fire and created cultural traditions that lasted longer than most species even exist. They proved that humans weren't just African apes, but global travelers capable of adapting to any environment. Every human species that came after, including us, inherited the achievements of Homo erectus. Our ability to walk long distances, our control of fire, our capacity for cultural transmission, our social complexity. These are all gifts from our travelling ancestors, earned through nearly 2 million years of exploration and adaptation. So when you walk down a street in a city thousands of miles from where humans evolved, you're following in the footsteps of Homo erectus. When you cook dinner over a flame, you're using technology they perfected. When you teach a child how to do something by demonstrating and explaining, you're continuing a tradition of knowledge transmission they established. Homo erectus didn't just survive. They set the stage for everything that would come after. They proved humans could go anywhere, survive anything, and build cultures that outlasted mountains. But the journey wasn't over, not even close. Because while Homo erectus was conquering Asia, something new was evolving back in Africa, something that would take the achievements of the travellers and push them even further. Human evolution was about to enter its next phase, and this time the changes would be even more dramatic. Now we come to something truly remarkable, something that changes everything we thought we knew about what it means to be human. Around 700,000 years ago, a new kind of human appeared. Not suddenly, evolution doesn't work that way, but gradually emerging from their Homo erectus ancestors like a photograph developing in solution. Details becoming clearer generation by generation. They called them Homo heidelbergensis, named after a jawbone found near Heidelberg, Germany in 1907. But that name barely begins to capture what these people actually were. They were the common ancestor, the source population from which 3 distinct human lineages would eventually emerge. Modern humans, Neanderthals and Denisovans, we all trace our roots back to these pioneers. Every person alive today, every person who has ever lived in the last 300,000 years, carries within them the genetic legacy of Homo heidelbergensis. Think about that for a moment. These weren't some distant evolutionary dead end. These were your direct ancestors, the people whose innovations, whose survival strategies, whose genetic adaptations made everything that came after possible. And they were spread everywhere, not just in one valley or one region, but across 3 continents. Fossil sites in Africa, Europe, and Western Asia all show evidence of heidelbergensis populations. They had achieved something none of their ancestors had managed: true global expansion across radically different environments. But they weren't just surviving in these places. They were thriving. They were innovating. They were becoming something the world had never seen before. Let's start with their brains, because that's where the real revolution was happening. Homo heidelbergensis had brains that were approaching modern human size. We're talking about 1,200 to 1,400 cubic centimeters, compared to about 1,350 for modern humans. The difference was minimal, maybe just 10 or 15% smaller on average. But here's what's crucial. Brain size alone doesn't tell you much. What matters is what you do with it. And archaeological evidence suggests heidelbergensis was doing things with their brains that would have been impossible for earlier humans. They were planning, not just hours ahead, not just days, but weeks and months into the future. They were thinking abstractly, conceptually, in ways that required them to hold multiple pieces of information in their minds simultaneously and manipulate them to solve complex problems. We know this because of what they left behind, and what they left behind changes everything. In 1995, archaeologists working in Schöningen, Germany, made one of the most important discoveries in human evolution. They found 8 wooden spears preserved in an ancient lake bed. These weren't crude, pointed sticks. These were sophisticated hunting weapons, carefully crafted from spruce trees, with the center of gravity positioned to optimize throwing distance and accuracy. The spears were 400,000 years old. Think about what that means. Homo heidelbergensis wasn't just using tools, they were engineering them. They understood aerodynamics even if they couldn't articulate the physics. They knew that moving the balance point toward the front of the spear made it fly straighter and hit harder. But the really impressive part is what else the site revealed. Along with the spears, archaeologists found the butchered remains of wild horses. Not just 1 or 2, but dozens, all killed and processed in the same location over many years. This wasn't opportunistic scavenging. This was systematic, planned hunting. These people were returning to specific locations season after season, intercepting horse migrations, and conducting organized group hunts that required coordination, communication, and shared knowledge. They were apex predators. For the first time in human evolution, we weren't just surviving alongside dangerous animals. We were at the top of the food chain, and they were doing this everywhere they lived. In Africa, heidelbergensis populations were hunting large game across the savannas, developing specialized tools for different prey species. In Europe, they were taking down massive Ice Age mammals, mammoths, woolly rhinos, giant deer. In Western Asia, they were exploiting coastal resources, hunting both land and sea animals. Each population was adapting to local conditions, but they were all using the same basic cognitive toolkit: advanced planning, cooperative hunting, systematic resource exploitation. These weren't instinctive behaviors. These were learned, culturally transmitted skills that had to be taught to each new generation. Which means they were teaching. They were passing on complex information from parents to children, from experienced hunters to novices. They had developed what anthropologists call cumulative culture, the ability to build on previous generations' knowledge rather than starting from scratch every time. But it wasn't just hunting that set them apart. They were also changing how they lived. Earlier humans, Homo erectus and their predecessors, were largely nomadic. They moved constantly, following resources, rarely staying in one place for more than a few days or weeks. Homo heidelbergensis started building homes. Now, we're not talking about modern houses with walls and roofs and foundations, but archaeological sites across Europe show evidence of constructed shelters, organized living spaces with different areas for different activities, stone arrangements that might have supported wooden frames, hearths positioned to maximize heat distribution, specialized work areas for toolmaking and food processing. At a site called Terra Amata in southern France, archaeologists found evidence of what might be 400,000-year-old huts, oval structures about 25 feet long, with stone-weighted walls and central hearths. The interpretation is controversial. Some researchers think the evidence could be natural formations, but if it's real, it would represent the oldest known human architecture. Even more impressive, some Heidelbergensis sites show evidence of repeated occupation. People returning to the same location year after year, generation after generation. This suggests they had developed a sense of place, of territory, of home that went beyond simple survival needs. They were creating communities, not just family groups that travelled together, but larger social structures that maintained connections across time and space. And they were doing something else, something that hints at the emergence of truly modern human consciousness. They might have been burying their dead. Now this is controversial. The archaeological evidence is ambiguous. There are several Heidelbergensis sites where human remains have been found, in what look like deliberately dug pits, sometimes with the bodies carefully positioned. But it's hard to prove intentionality when you're dealing with 300,000 or 400,000-year-old sites. Natural processes can create patterns that look deliberate. But if Heidelbergensis was practicing burial, even occasionally, even in simple forms, it would mean something profound. It would mean they had developed an awareness of death as something meaningful, something that required ritual response. It would mean they could conceive of individuals as existing beyond their immediate physical presence, that the death of a group member mattered enough to merit special treatment. This is the foundation of symbolic thinking, the ability to represent one thing with another, to create meaning that exists beyond immediate sensory experience. This is what separates human consciousness from animal awareness. And there are other hints of symbolic behaviour. Some Heidelbergensis sites have yielded objects with no obvious practical function. Fossils collected and carried long distances. Unusual stones that seem to have been valued for their aesthetic properties. Ochre, that red mineral pigment that humans have been obsessed with for hundreds of thousands of years, showing up at archaeological sites with no clear practical purpose. Why would you collect ochre if you weren't using it decoratively? Why would you carry an interesting shell or crystal for hundreds of miles if it didn't mean something to you? These are small things, easy to dismiss as coincidence or modern projection. But taken together, they suggest Heidelbergensis was starting to think symbolically, to create meaning, to see the world not just as a collection of resources and dangers, but as something more, something that could be interpreted and represented and shared. But perhaps the most remarkable thing about Homo heidelbergensis was their ability to adapt to radically different environments. This wasn't just biological adaptation through natural selection, though that was certainly happening. This was cultural adaptation, behavioral flexibility, that allowed the same basic species to thrive in African heat and European Ice Age cold. In Africa, Heidelbergensis populations faced the same environmental challenges their ancestors had dealt with for millions of years. Dry seasons and wet seasons, predators and prey, the constant search for water and shelter. But they were dealing with them more effectively. They had better tools, better hunting strategies, more sophisticated social organization. African Heidelbergensis developed what archaeologists call the Acheulean tool tradition to its highest form. These weren't just hand axes anymore. They were carefully crafted, symmetrical, beautiful even, showing a level of skill and aesthetic sense that went far beyond simple utility. In Europe, things were completely different. Heidelbergensis populations there had to deal with Ice Age conditions that would have killed their African cousins within weeks, winters that lasted 8 months, temperatures that regularly dropped below freezing, landscapes dominated by tundra and sparse woodlands. They adapted by becoming more robust. European heidelbergensis skeletons show heavier bone structure, greater muscle mass, larger nasal passages to warm incoming air. These changes were already pointing toward what their descendants would become. The Neanderthals were evolving from European heidelbergensis populations, adapting over hundreds of thousands of years to Ice Age conditions. But the adaptation wasn't just physical. European heidelbergensis developed specialized cold weather technologies. They learned to make clothing from animal skins, though direct evidence is scarce since leather rarely survives. They figured out how to maintain fire through long winters, how to store food, how to find resources when the landscape was buried under snow. Most impressively, they learned to hunt the massive Ice Age megafauna that dominated European landscapes. Mammoths weighing 10 tons or more, woolly rhinos with horns that could gore a person like a knife through paper, cave bears larger and more dangerous than modern grizzlies. Taking down these animals required incredible courage, sophisticated planning, and tight group coordination. One mistake, and you weren't just going hungry. You were getting trampled or gored or eaten. But heidelbergensis figured it out. Sites across Europe show evidence of successful mammoth kills, animals that could feed a group for weeks if properly butchered and preserved. In Western Asia, populations were dealing with yet another set of conditions. Seasonal climates that varied between Mediterranean warmth and mountain cold. Landscapes that ranged from coastal plains to highland plateaus. These populations had to be generalists, capable of exploiting whatever resources were available as seasons changed and conditions shifted. And somehow, all these populations maintained genetic connections. They were spreading out, adapting to local conditions, but they weren't becoming separate species. Not yet. Fossil evidence shows that heidelbergensis from Africa, Europe, and Asia were all still fundamentally the same, still capable of interbreeding if their ranges overlapped, still sharing the same basic body plan and cognitive abilities. But the seeds of divergence were being planted. As populations adapted to radically different environments over hundreds of thousands of years, they were accumulating genetic differences. Small changes in one generation, slightly larger differences in the next, until eventually you had populations that looked distinctly different from each other. By about 400,000 years ago, you can start to see the split happening. European populations were becoming more robust, developing features that would eventually characterize Neanderthals. African populations were remaining more gracile, more lightly built, on the path toward modern humans. Asian populations were developing their own unique characteristics, heading toward what would become the Denisovans. The common ancestor was fragmenting into multiple lineages, not suddenly, not cleanly, but gradually, messily, with populations splitting and recombining and splitting again over hundreds of thousands of years. By 200,000 years ago, Homo heidelbergensis as a distinct species was essentially gone, but they weren't extinct. They had transformed into something else. Multiple something elses. Their African descendants were becoming Homo sapiens. Their European descendants were becoming Neanderthals. Their Asian descendants were becoming Denisovans. The pioneers had given rise to the most successful radiation of human species in history. 3 distinct lineages that would dominate the planet for the next 200,000 years. All carrying forward the innovations heidelbergensis had pioneered. Advanced hunting, sophisticated tools, complex social organization, the beginnings of symbolic thought. Everything that came after, everything that would make us human, started here. With these pioneers who spread across 3 continents, who adapted to every environment they encountered, who developed the cognitive and cultural foundations on which all subsequent human achievement would be built. They were the common thread connecting us to our Neanderthal cousins, and our mysterious Denisovan relatives. They were the source from which modern humanity ultimately emerged. They were the pioneers who proved that humans could thrive anywhere, adapt to anything, overcome any challenge. And their story was just beginning. Let's talk about the most misunderstood humans who ever lived. For over a century, Neanderthals have been portrayed as grunting cavemen, brutish, stupid, evolutionary dead ends who couldn't compete with our supposedly superior ancestors. You've seen the images, hunched over, dragging clubs, with vacant stares and protruding jaws. The very word Neanderthal became an insult meaning primitive or backward. There's just one problem with this story. Almost everything we thought we knew about Neanderthals was wrong. Dead wrong. The real Neanderthals were sophisticated, intelligent, and in many ways more physically capable than modern humans. They created art. They wore jewellery. They cared for their sick and elderly. They buried their dead with what appears to be genuine emotion and ritual. They spoke. They sang. And they survived in environments so harsh that most modern humans would die within days. And here's the kicker. They didn't really go extinct. Not entirely. Because 1 to 4% of your DNA, if you're of non-African ancestry, came from them. Right now, as you're listening to this, you're carrying Neanderthal genes that affect everything from your immune response to your tolerance for pain, from your skin colour to your risk of depression. You are quite literally part Neanderthal, so how did we get them so wrong for so long? And what was life really like for these remarkable people who dominated Europe and Western Asia for nearly 400,000 years? The story begins around 400,000 years ago when populations of Homo heidelbergensis living in Europe began adapting to the brutal conditions of the Ice Age. And when I say brutal, I mean conditions that would make modern survival experts weep. Winters lasting 8 months or more, temperatures regularly dropping to -30, -40 degrees Celsius, vast ice sheets covering most of northern Europe, pushing all life into narrow corridors where resources were scarce and competition was deadly. The populations that stayed in these conditions had two choices: adapt or die. They adapted. Over hundreds of thousands of years, natural selection sculpted them into perhaps the most cold adapted humans who ever lived. Their bodies became incredibly robust, with bone density that modern humans never achieve. Their average male stood about 5'5", tall, but weighed around 185 pounds, all of it muscle and dense bone. They were built like wrestlers, with barrel chests and limbs that were shorter relative to their torso. This body plan wasn't just about strength, it was about thermodynamics. In cold environments, you want to minimize your surface area relative to your volume. Less surface area means less heat loss. Neanderthals were living thermoses, perfectly designed to retain body heat in Arctic conditions. But their most distinctive adaptation was their face. Those famous Neanderthal features, the heavy brow ridges, the large nose, the protruding mid-face, these weren't signs of primitiveness. They were climate engineering. That massive nasal cavity acted as a biological heat exchanger, warming and humidifying the frigid, dry air before it reached their lungs. Without this adaptation, they would have suffered constant respiratory damage from breathing Arctic air. Their brains were actually larger than ours. On average, Neanderthal cranial capacity was 1,520 cubic centimeters, compared to modern humans' 1,400. Now, brain size doesn't directly equal intelligence, but it tells us their brains were doing something that required a lot of neural real estate. So what were they doing with those big brains? Surviving in ways that would impress modern special forces. Let's start with their hunting capabilities. For decades, scientists assumed Neanderthals were simple ambush hunters, maybe stabbing prey with wooden spears at close range. The evidence now tells a very different story. Neanderthal hunting sites show evidence of strategic planned kills requiring remarkable coordination and intelligence. They drove entire herds of horses and bison off cliffs. They ambushed mammoths at river crossings. They tracked reindeer migrations across hundreds of miles, timing their movements to intercept herds at optimal locations. The weapon analysis is particularly revealing. Neanderthals created sophisticated wooden spears with fire-hardened tips. Some of these spears, found preserved in German bogs, are over 300,000 years old and show evidence of careful craftsmanship. Weight distribution analysis shows they were balanced for throwing, not just thrusting. Neanderthals were throwing spears with deadly accuracy at distances up to 20 meters. But they weren't just hunters. They were master craftspeople whose tool-making abilities rivaled and sometimes exceeded those of early modern humans. They developed what archaeologists call Levallois technique, a method of stone tool production that requires planning several steps ahead. You have to look at a raw piece of stone and visualize the finished tool hidden inside it. Then you have to carefully shape the stone through a precise sequence of strikes to release that tool. This isn't mindless chipping. This is three-dimensional spatial reasoning, planning, and fine motor control. It's closer to sculpture than survival. The tools they produced were remarkably standardized. A Neanderthal hand axe from France looks almost identical to one from Iraq, separated by thousands of miles and thousands of years. This standardization indicates cultural learning, teaching techniques passed down through generations. But tools and hunting strategies aren't what really challenge our old assumptions about Neanderthals. What really changes the picture is the evidence of their inner lives, their capacity for symbolic thinking, art, and compassion. In 2018, researchers confirmed something that shocked the archaeological community. Cave paintings in Spain, long assumed to be the work of modern humans, were actually created by Neanderthals. And not just any paintings. These were abstract symbols, geometric patterns, handprints, art for art's sake. They were made at least 65,000 years ago, 20,000 years before modern humans even arrived in Europe. Think about what that means. Neanderthals weren't just surviving, they were creating meaning, expressing themselves, leaving marks that said, I was here, I thought, I felt. They wore jewellery, pierced shells collected from beaches miles from their cave homes, eagle talons carved with notches and hung on sinew cords. Some researchers think they wore feathers, decorating themselves like modern humans do. They buried their dead, not just disposing of bodies, but actual burials with care and apparent ritual. At Shanidar Cave in Iraq, a Neanderthal was buried with pollen evidence suggesting flowers were placed in the grave. While this specific interpretation is debated, the burial itself is undeniable. They dug a pit, placed the body carefully, covered it with stones. They cared for their injured and elderly. This is perhaps the most moving evidence we have of Neanderthal humanity. At multiple sites, we find individuals who survived for years with debilitating injuries. A Neanderthal from Shanidar had a withered arm, probably useless from birth, yet lived to old age. Another had been blind in one eye and suffered from severe arthritis, yet survived into his 50s. These individuals could not have survived alone. Someone fed them, protected them, cared for them, not because they were useful, but because they were valued. Because they were family. This is compassion. This is humanity. But could they speak? This has been one of the biggest debates in paleoanthropology. For years, some scientists argue that Neanderthals lack the anatomical structures necessary for complex speech. The evidence now overwhelmingly suggests they could speak, and speak well. First, the hyoid bone. This small bone in the throat supports the tongue and is crucial for speech. Neanderthal hyoid bones are virtually identical to ours. They had the hardware. Second, the FOXP2 gene, This gene is involved in language development. Neanderthals had the same version we do. They had the software. Third, their ear structure. Analysis of Neanderthal ear bones shows they were most sensitive to the frequency ranges used in human speech. They were literally tuned to hear language. Finally, their cultural complexity. The standardized tool production, the apparent teaching of complex skills, the symbolic behavior, all of this would be nearly impossible without language. You can't teach someone to make a levallois flake or explain the meaning of a burial ritual through grunts and gestures. They spoke. They probably sang. They told stories around fires during those endless Ice Age winters. We just can't hear those voices anymore. So if they were so successful, so well adapted, so intelligent, what happened to them? Why did they disappear? The mystery of Neanderthal extinction has generated dozens of theories, some more plausible than others. Let's walk through the main ones. Theory 1. Climate change. Around 40,000 years ago, the climate became increasingly unstable. Rapid fluctuations between warm and cold periods might have disrupted the large game herds Neanderthals depended on. But Neanderthals had survived multiple climate fluctuations before. Why would this one finish them? Theory 2. Competition with modern humans. Our ancestors arrived in Europe around 45,000 years ago. Within 5,000 years, Neanderthals were gone. That's suspicious timing. Modern humans might have been slightly more efficient hunters, slightly better at exploiting resources. Over thousands of years, those slight advantages could compound. But there's no evidence of systematic warfare, no massacre sites, no indications that modern humans actively genocided their Neanderthal cousins. Theory 3. Disease. Modern humans arriving from Africa might have brought tropical diseases that Neanderthals had no immunity to. This is the depressingly familiar pattern of colonization. New people arrive, old populations die of novel diseases. It's plausible, but we have no direct evidence. Theory 4, and this is the theory that's gaining the most traction. They didn't go extinct. They were absorbed. Here's where your own DNA enters the story. When scientists first sequenced the Neanderthal genome in 2010, they discovered something remarkable. Modern humans of European and Asian ancestry carry 1 to 4% Neanderthal DNA. African populations whose ancestors never left Africa carry almost none. This means our ancestors didn't just encounter Neanderthals, they mated with them, had children with them. And those hybrid children survived, reproduced, and passed Neanderthal genes down through 1,500 generations to reach you. The interbreeding wasn't a one-time thing. Genetic analysis shows multiple episodes across thousands of years. Sometimes modern human men and Neanderthal women. Sometimes Neanderthal men and modern human women. Real relationships, real families. Some of those Neanderthal genes proved useful and spread through modern human populations. You've got Neanderthal genes affecting your immune system, helping you fight off infections. Neanderthal genes influencing your skin and hair, helping you adapt to UV levels outside Africa. Neanderthal genes affecting your pain tolerance, your blood clotting, even your response to depression. But the mixing went both ways. Modern human genes flowed into Neanderthal populations too. By the end, the last Neanderthals were hybrids themselves, carrying modern human DNA. So maybe they didn't go extinct. Maybe they were just outnumbered. As modern human populations expanded rapidly, small Neanderthal groups were absorbed, generation by generation, until there were no more pure Neanderthals left. Just humans carrying pieces of Neanderthal heritage. In the limestone caves of southern Spain, we found some of the last evidence of Neanderthal presence. Sites dated to about 37,000 years ago. Small groups making the same tools their ancestors had made for 300,000 years. Still hunting, still making art, still burying their dead. Then, Silence. The archaeological record goes quiet. No more Neanderthal sites. No more distinctive tools. Just modern humans, spreading across Europe, carrying Neanderthal genes, but no longer encountering living Neanderthals. The world must have been lonelier after they were gone. For hundreds of thousands of years, Earth had been home to multiple human species, different kinds of people living in different ways, but all unmistakably human, all capable of love, grief, joy, curiosity. Then there was just us, Homo sapiens, alone, but not entirely alone, because every time someone with European or Asian ancestry looks in the mirror, they're seen a face shaped partly by Neanderthal genes. Every time they fight off an infection using a Neanderthal immune gene, every time they feel pain responses influenced by Neanderthal variants, they're experiencing the legacy of these remarkable people. The popular image of Neanderthals as primitive brutes wasn't just wrong, it was a failure of imagination. We looked at people who were different from us and assumed they must be inferior. We let superficial physical differences blind us to the profound similarities. They loved their children. They cared for their elderly. They created beauty. They wondered about death and invented rituals to honor it. They spoke, sang, taught, and learned. They survived in conditions that would kill most of us within days. They were human. Not human like us, but human nonetheless. And their story isn't over. It lives on in our genes, in the DNA that helps us survive in harsh climates, fight off diseases and adapt to new environments. Every modern human of non-African ancestry is a living memorial to the Neanderthals. We are their children too, the last carriers of their legacy, the proof that they lived, loved, and left their mark on the species that would inherit the earth. But our story, the story of Homo sapiens, was just beginning. Because while Neanderthals were perfecting survival in the Ice Age, something extraordinary was happening back in Africa. Something that would change everything. Around 300,000 years ago, in the grasslands and forests of Africa, something new appeared. Not dramatically different, not obviously special. If you saw one of these early Homo sapiens walking past, you might mistake them for Homo heidelbergensis at first glance. Similar height, similar build, using similar tools, but look closer, the skull is different. Higher, rounder, with a less pronounced brow ridge. The face is flatter, almost delicate compared to earlier humans. The chin, that peculiar jutting feature that serves no obvious purpose, is there for the first time in human history. These were your direct ancestors, the species that would eventually inherit the earth. But they didn't know that yet. For their first 230,000 years of existence, Homo sapiens were just another human species, competing with Neanderthals, Denisovans, Homo erectus populations in Asia, even tiny Homo floresiensis on Indonesian islands. They were successful, sure. They survived and spread across Africa. But they weren't special. Not yet. They made the same kinds of stone tools their ancestors had been making for hundreds of thousands of years. They lived in small groups, probably no more than 150 individuals who actually knew each other. They hunted, gathered, raised children, told stories around fires. They were smart, capable, adaptable. But so were Neanderthals. So were Denisovans. For over 200,000 years, Homo sapiens were just one player in a crowded field of human species. Then around 70,000 years ago, something changed. Nobody knows exactly what. There's no obvious environmental trigger, no massive climate shift or catastrophic event that can explain it. But the archaeological record shows an explosion of new behaviours appearing across Africa within just a few thousand years. Archaeologists call it the cognitive revolution, and it transformed our species from just another group of smart apes into something unprecedented in the history of life on Earth. The first signs were artistic. Someone in South Africa, about 75,000 years ago, picked up a piece of red ochre and carefully carved a geometric pattern into it. Cross-hatching, repeated and deliberate. Not a tool, not something functional. Pure expression, pure symbol. Someone else, maybe in the same group, maybe thousands of miles away, started drilling holes in seashells and stringing them together as jewellery. Beads, decoration. Again, no practical purpose. These were objects that existed purely to communicate something. Status, identity, group membership, or maybe just the simple human impulse that says, I was here, I made this, I matter. Within a few thousand years, similar objects start appearing all over Africa. Carved ostrich eggs, decorated bone fragments, pigments ground up and mixed, probably for body painting, and most tellingly, long-distance trade networks carrying materials hundreds of miles from their sources. Someone was organising expeditions to specific locations to gather specific materials. Someone was remembering where good ochre deposits were, where the best shells could be found, which stone made the sharpest blades. Someone was planning months in advance, coordinating with other groups, building relationships that could span lifetimes. This wasn't just intelligence. Neanderthals were intelligent. This was something else. Something that let humans imagine things that didn't exist yet, plan for distant futures, coordinate complex social activities across time and space. Scientists debate what actually happened during the cognitive revolution. Some think it was genetic, a mutation that rewired our brains in some subtle but crucial way. Others argue it was cultural, a new technology that had nothing to do with biology. That technology was language, not simple language, not just basic communication about immediate needs and dangers. Complex, recursive, grammatically sophisticated language. Language that could express abstract concepts. Language that could tell stories about things that never happened. Language that could ask, what if? Here's what makes human language unique. Every other animal, communication system is limited to immediate reality. A monkey can call out leopard to warn its group. But it can't say, remember that leopard we saw last summer? Or, what if a leopard attacks during the dry season? Or, I had a dream about a leopard last night. It definitely can't say, let me tell you a story about the first leopard who made a deal with the moon. Human language can do all of these things. We can talk about past and future, about possibilities and impossibilities, about things that exist only in our imagination. We can create shared fictions, collective beliefs that exist nowhere except in human minds, but can motivate coordinated action by millions of people. Money, nations, gods, corporations, justice. All of these are stories we tell each other, fictions we collectively agree to believe in, and that ability, the capacity to create and share fictional realities, is what transformed Homo sapiens from just another smart animal into the planet's dominant species. With complex language came cumulative culture. Each generation could build on the knowledge of the previous one, not just through direct teaching, but through stories, myths, explanations. A young hunter could learn from elders who hadn't hunted in decades, absorbing their lifetime of experience in a few conversations. A toolmaker could perfect techniques developed by ancestors she never met, innovations preserved in tribal memory. Knowledge became immortal. It no longer died with individuals. It could be stored in collective memory, in songs and stories and ritual practices, passed down through generations with remarkable fidelity. This meant human adaptation could happen at cultural speed, not evolutionary speed. A new hunting technique that worked could spread through an entire population in years, not millennia. A better way to process poisonous plants could save thousands of lives without waiting for genetic adaptation. Humans could adapt to new environments in generations, not tens of thousands of years. And then they proved it. Around 70,000 to 60,000 years ago, small groups of Homo sapiens started leaving Africa. Not the first time humans had left, Homo erectus beat them by nearly 2 million years. But this time was different. These humans didn't just spread slowly into adjacent territories, they exploded across the planet. Within 10,000 years, maybe less, Homo sapiens had reached Australia. Think about that. Australia required crossing at least 60 miles of open ocean. No land bridges, no island hopping, just deliberate seafaring, boats built and provisioned, expeditions planned and executed. This wasn't accidental. Someone had to organize it. Someone had to convince dozens of people to climb into boats and sail toward a horizon they'd never seen before, toward a land they could only imagine existed. That's the power of language. That's what fictional thinking enables. Trust me, there's land out there. We'll find it if we keep sailing east. And somehow, impossibly, they did. By 45,000 years ago, Homo sapiens had reached Europe, moving into territories that had been Neanderthal homelands for 300,000 years. They brought with them technologies the Neanderthals had never imagined, throwing spears that could kill from distances Neanderthals could barely believe, sewing needles made from bone that allowed creation of fitted weatherproof clothing, fishing hooks, nets, traps for catching birds and small mammals. But most importantly, they brought art. The caves of Europe from this period explode with imagery. Not random marks, not crude scratches, sophisticated, skilled, beautiful representations of animals, humans, abstract symbols. The cave paintings at Chauvet in France, created 36,000 years ago, show horses, lions, rhinoceros rendered with such anatomical precision and artistic skill that they look like they could be modern wildlife illustrations. Whoever painted these wasn't just documenting what they saw. They were interpreting, expressing, creating something that existed purely in the realm of aesthetic experience. Alongside the cave paintings came Venus figurines, small carved representations of female bodies, voluptuous and stylized, found from France to Siberia. Nobody knows what they meant. Fertility symbols, religious objects, early pornography. But their widespread distribution suggests shared cultural meanings, common stories that spread across thousands of miles of Ice Age Europe. The Neanderthals watched all this happening. They even tried to imitate some of it. Late Neanderthal sites show evidence of body decoration, symbolic objects, even cave paintings, but it was too little, too late. By 40,000 years ago, Neanderthal populations were in sharp decline. Not because Homo sapiens killed them all, though there was probably some violence. Mostly they lost the competition for resources. When Homo sapiens and Neanderthals competed for the same hunting territories, the same caves, the same resources, Homo sapiens won. Not because they were stronger or tougher, Neanderthals were actually more robust. Not even because they were smarter in some abstract sense. They won because they could cooperate in larger groups, coordinate more complex activities, share information more effectively. A Neanderthal band might number 30 individuals. A Homo sapiens tribe could coordinate actions between multiple bands totaling hundreds of people, all working toward shared goals based on shared stories about identity and purpose. That's an overwhelming advantage. By 40,000 years ago, the last Neanderthals were gone. The Denisovans disappeared around the same time, though some populations may have survived longer in isolated Asian regions. Homo erectus, which had survived for nearly 2 million years, finally went extinct. Homo floresiensis, the tiny hobbit humans of Indonesia, vanished. By 30,000 years ago, for the first time in millions of years, only one human species walked the earth. Homo sapiens, the storytellers, the believers in shared fictions, the species that could imagine things that didn't exist and then bring them into reality through collective action. But we didn't entirely replace the other species, we absorbed them. Genetic analysis shows that most modern humans outside Africa carry 1-4% Neanderthal DNA. Asian populations carry similar amounts of Denisovan DNA. Papua New Guineans carry up to 5%. We didn't just outcompete our evolutionary cousins, we interbred with them, and some of those ancient genes are still doing important work in our bodies today. The Neanderthal gene variants that help modern Europeans and Asians fight certain diseases. The Denisovan genes that help Tibetans live at high altitude. The immune system components we inherited from multiple ancient human species. We are walking museums of human evolutionary history, carrying pieces of extinct species in every cell. For the next 20,000 years, Homo sapiens continued spreading. By 15,000 years ago, they had reached the Americas, crossing the Bering Land Bridge during the last ice age or possibly travelling down the Pacific coast in boats. By 13,000 years ago, they had reached the southern tip of South America. An entire hemisphere, from Arctic tundra to Amazonian rainforest to Patagonian steppes, colonized in less than 2,000 years. Everywhere humans went, they adapted. Arctic populations developed shorter limbs and rounder bodies to conserve heat. Tropical populations retained longer limbs to dissipate it. High-altitude populations developed enlarged lungs and modified blood chemistry. Desert peoples learned to survive on minimal water, and everywhere they transformed the landscape. The megafauna extinctions that swept across continents, giant ground sloths, woolly mammoths, massive wombats, all coincided suspiciously with human arrival. We were apex predators now, armed with sophisticated weapons and coordinated hunting strategies. Animals that had never encountered humans had no instinctive fear of us. They learned too late. But the biggest transformation was still to come. Around 12,000 years ago, in multiple locations across the world, humans stopped moving. They had been nomadic for millions of years, following herds, tracking seasonal resources, never staying in one place longer than circumstances required. Then, gradually, some groups started settling down. The agricultural revolution wasn't really revolutionary at first. It started small, probably accidentally. Someone noticed that wild wheat grew especially thick where grain had been spilled the previous year. Someone else noticed that the best fruit came from trees near campsites, where seeds had been thrown away. Gradually, unconsciously, humans started manipulating the plants they depended on, saving the best seeds, clearing competing plants, watering during dry spells. Within a few thousand years, they had transformed wild grasses into wheat, barley, and rice, wild fruits into apples, figs, and dates, wild animals into sheep, goats, cattle, pigs, and in the process, they transformed themselves. Agricultural societies could support much larger populations than hunter-gatherer bands. A few square miles of farmland could feed hundreds of people. Villages grew into towns. Towns grew into cities. Cities grew into civilizations. But agriculture came with costs. Hunter-gatherers had been remarkably healthy, eating diverse diets and getting plenty of exercise. Early farmers ate narrower diets dominated by a few starchy crops. Skeletal evidence shows they had more cavities, more nutritional deficiencies, more infectious diseases. They worked longer hours for less certain rewards. One drought, one plague of locusts, one crop failure could mean starvation for entire communities. And yet agriculture kept spreading because it could support more people. A valley that could sustain 100 hunter-gatherers could support 10,000 farmers. When the two groups competed for territory, the farmers won through sheer numbers. By 5,000 years ago, most of humanity lived in agricultural societies, and those societies were developing something unprecedented: civilization, writing, mathematics, metallurgy, architecture, philosophy, art, science. All the achievements we associate with human advancement, all built on the foundation of agricultural surplus and settled populations. But we never stopped being the same species that evolved in African grasslands 300,000 years ago. Our brains are essentially identical to those of our Paleolithic ancestors. The cognitive toolkit that let them survive ice ages and cross oceans is the same one we use to write poetry and build spacecraft. We still think in stories. We still organize ourselves around shared fictions. We still cooperate most effectively with people who share our tribal identity. We're still carrying the genetic signature of ancient bottlenecks, the DNA fragments from extinct human species, the evolutionary adaptations from millions of years of climbing, walking, running across African landscapes. Your body is a museum of evolutionary history. Your spine curves in a specific way because your ancestors walked upright. Your shoulders rotate freely because they climbed trees. Your brain has a massively overdeveloped prefrontal cortex because your ancestors needed to understand complex social relationships and imagine futures that didn't exist yet. You can digest milk into adulthood because some of your ancestors started herding cattle 10,000 years ago. You might have Neanderthal genes helping your immune system fight diseases your African ancestors never encountered. Every quirk, every strange feature, every seemingly pointless bit of anatomy tells a story about survival, adaptation, the long journey that made you possible. And the journey continues. We're still evolving, still adapting, though modern medicine and technology have changed the selection pressures dramatically. We've transformed the planet to suit ourselves, built civilizations that would seem like magic to our ancestors, split the atom and walked on the moon. But we're still the storytellers, still the species that believes in shared fictions and makes them real through collective action, still carrying in every cell the memory of millions of years of evolution, billions of ancestors who survived long enough to pass on their genes. You are the latest chapter in the longest story ever told, the story of how a small, vulnerable ape learned to walk upright, use tools, control fire, speak complex languages, and eventually imagine futures so compelling that we could bring them into existence through sheer force of collective will. Every human alive today is the descendant of survivors, carriers of genes that made it through ice ages, volcanic winters, droughts, plagues, bottlenecks that reduced human populations to desperate handfuls clinging to survival in isolated refuges. We are the species that should have gone extinct a dozen times, but somehow, impossibly, survived. And now there are 8 billion of us, living on every continent, speaking thousands of languages, believing in countless different stories about who we are and why we're here. But underneath all that diversity, we're still one species, still carrying the same basic genome, still capable of interbreeding regardless of how different we look, still fundamentally the same storytelling apes who painted caves in France and crossed oceans to unknown lands because someone said, "Trust me, there's something better out there." The question now is what stories we'll tell next, what futures we'll imagine, what collective fictions we'll believe in strongly enough to make them real. Because that's our superpower, our evolutionary advantage, the trait that let us outlast every other human species and dominate the planet. We can imagine things that don't exist yet, and then cooperate in vast numbers to bring them into existence. We're still writing the story of humanity, still evolving, still adapting, still surviving, against odds that would terrify our ancestors. The journey that made us human hasn't ended. If anything, it's accelerating, and you're part of it. Every choice you make, every child you raise or influence, every idea you share or create, you're shaping the next chapter of the longest, strangest, most improbable story in the history of life on Earth. The story of how a small band of African apes learned to tell stories so compelling that they changed the world. So here we are, you and me, at the end of a 7 million year journey. 7 million years from a small ape-like creature walking through the forest of Chad to you, lying in bed, listening to this story on a device that would have seemed like pure magic to every single one of your ancestors. Think about what we've just travelled through together. Sahelanthropus, taking those first uncertain steps on 2 legs. Australopithecus, perfecting bipedalism but still sleeping in trees. Homo habilis, picking up stones and seeing tools. Homo erectus, walking out of Africa with fire in hand. Homo heidelbergensis, developing the first complex societies. Neanderthals, surviving Ice Age Europe with strength and intelligence we're only beginning to appreciate. And finally, Homo sapiens, us, the storytellers who survived when all the other human species disappeared. But here's the thing that should keep you thinking as you drift off to sleep. This story isn't over, not even close. We like to think of ourselves as the finished product, the culmination of evolution, the species that's done evolving. But that's not how it works. That's never been how it works. Every single one of those extinct human species probably thought they were pretty well adapted too. Homo erectus survived for nearly 2 million years. 2 million years. Modern humans have only been around for 300,000. By erectus standards, we're still just getting started. Right now, at this exact moment, human evolution is continuing. It's happening slower than it used to because we've removed most of the extreme selection pressures through technology and medicine. But it's still happening. Populations living at high altitudes are developing better oxygen processing abilities. Communities that adopted dairy farming 10,000 years ago evolved lactose tolerance. People living in malaria zones developed genetic resistance. These aren't ancient adaptations. These are evolutionary changes that happened within the last few thousand years, within recorded history. And it's still going. Scientists have identified hundreds of genes that are currently under active selection in human populations. We're becoming better at processing modern diets. We're developing resistance to new diseases. We're even seeing subtle changes in brain structure as our species adapts to increasingly complex social and technological environments. Where will we be in another million years? If humans still exist, and that's a big if, we'll probably look as different from modern humans as we look from Homo erectus. Maybe we'll be taller or shorter. Maybe our brains will be larger or more efficient. Maybe we'll have developed new sensory capabilities or lost old ones we don't need anymore. Or maybe we'll have split into multiple species again, like our ancestors did after the bottleneck. Populations colonizing different planets could diverge enough that they can no longer interbreed. The space-adapted humans of the future might look back on us the way we look back on Australopithecus, ancestor species that made everything possible, but were ultimately just one step on a much longer journey. But here's what really gets me. What should really make you pause and think as you're falling asleep? We're not special. Because we're the end result. We're not the goal evolution was working toward. We're not the pinnacle of anything. We're just the current survivors. We're the branch that happened to make it through the last few 100,000 years of planetary chaos. We're the ones who got lucky enough, smart enough, adaptable enough to still be here when dozens of other human species went extinct. Every person alive today, all 8 billion of us, we're connected through an unbroken chain that stretches back through the Neanderthals and Denisovans we interbred with, through the bottleneck survivors who refused to give up, through Homo erectus walking across continents, through habilis making the first tools, through Australopithecus coming down from the trees, all the way back to Sahelanthropus taking those first bipedal steps in an African forest 7 million years ago. That's your family tree. That's the journey that created you. Every innovation, every adaptation, every desperate survival against impossible odds, It all led to this moment, to you, lying here in the darkness, thinking about where you came from and where you might be going. So as you drift off to sleep tonight, carry this thought with you. You're the latest chapter in the greatest story ever told. You're evolution in progress. You're the temporary custodian of genes that survived ice ages, volcanic winters, climate catastrophes, and extinction events that killed off dozens of other human species. And somewhere in the distant future, someone or something will look back on you the way you're looking back on Sahelanthropus tonight. Wondering what it was like to be you. Wondering what your world was like. Wondering what happened next. Thank you for joining me on this journey through deep time. If you enjoyed this evolutionary expedition, leave a like and let me know in the comments where you're listening from. Subscribe for more history to help you sleep. And remember, you're not just watching history, you're making it. Sweet dreams, fellow survivor. See you in the next era.